Okay, Friday, Rocktober 1st, baby. So Rocktober in calculus. So good news and bad news. We've been through August and September already. The bad news is you're only halfway through chapter 1. So like you really need to get going. This is not okay. Anyway, congrats to Elijah and Hannah, and Elijah got the king, so that's awesome. So we all applaud that. So no pressure. Lead the world to better things. All right. Nobody seemed to want to do number 31 or help Kenya with her question, and then it turns like everybody has that question, and nobody got it. Did we agree on that?
Eric said he got 32.
I got 32.
Oh, we got
Everybody got 32.
Oh, everybody got 32. Is that the one that she was asking on?
Yeah.
All right, I gotta get sure blank whiteboard. All right, so we got people joining in. Perfect.
Oh, I got 32.
Anyway, should be on there. So number 31, what was number 31? You gonna make me look that up? What page is this? Anybody? Page 58. We're on page 800 something in Calc 3, which is, all right. So page 51, what page?
Down.
31. So we have f of x equals x squared. Whoa. If x squared. If x is less than or equal to 2, ax plus b. If negative 2 is less than x is less than 2, and 2x minus 6 if x is greater than 2 or equal to 2. All right. So anyway, we want to find the values of a and b so that the limits, that's a b here, right? So that find a and b so that the limits exist from as you approach negative 2 and 2. Yeah. Look at this. Okay, how's that? Is that better? Huh?
Hold up.
Am I sharing my?
No, you are. Yeah.
Oh.
We won't load.
All right.
I have it.
Well, anyway, so if we want the limit as x approaches negative 2 of f of x to exist, I need to look at the left-handed and right-handed limit, correct? So the left-handed limit, we were using, blue from the left, weren't we? I'm going to use green because I already started using blue. Well, actually, I'll just stay with blue. And so I want to look at the left-handed limit. What would the left-handed limit be? Well, first of all, this is a polynomial. So, whoops, is that approaching negative 2? Yeah, I lost my negative. So as I approach from the left, basically what's our graph look like? Let's see if we can graph it. So at negative 2, we have going in, left of that is x squared, which looks like this is a parabola, right? And it says less than or equal. And if I plug in negative 2, I get a height of what? 4? And then what's the right one? 2x minus 6 if x is greater than or equal to 2. So if I plug in 2 there, that's a polynomial as well, right? So I can plug in, that's 4 minus 6, which is negative 2, which is here. And then that's a line with slope of positive 2, right? That doesn't change on your screen? Like it just blew it up and made it big.
Yeah, just.
The graph is like separate. Yeah. No.
Where'd it go? All right. Anyway, so that'll go this. What, did that move?
Yeah.
Like, knock it off. I hate this thing. You people need to start showing up to class. Quit it. It won't draw anymore. I have no idea what happened, so I'm going to clear it. I have no idea what. All right. You gotta be kidding me. Where did it go? It won't write. Oh my God. I don't get my video. I gotta. Hi. All right. It's irritating me, so I'm just gonna use the board. So where do I gotta stop? Right
We're graphing it.
here. And I can use the rest of the board. All right. So anyway, let's just graph this up here. So at -2, we were up at 4, right? And it was x squared. Over at 2, we were down at 2, -2. And it was a line with slope 2. And then I want the limit to exist from both sides. So what has to be the case? What has to be the case is I got to connect these, right? And it's a line because it was ax plus b, right? So this is ax plus b right here for that one, right? X squared for this one and 2x minus 6, is that right, for that one? Which was also a line. So if I want the limit as x approaches -2 to exist, of f of x, if it exists, then that means the left-handed limit has to exist and equal the right-handed limit. So let's look at the left-handed limit for that one. Basically, it's the limit as x approaches -2 from the left of x squared, which what can I do? That's a poly, right? So let's go ahead and plug it in. I know I made you write that out in section 1.5, right? But limit of the exponent is the exponent of the limit, so I can plug in -2. Quantity squared is 4, right? Because it's poly. So we'll just use the shorthand version of that rule. What's the right-hand limit at -2? Right-handed limit as x approaches -2 from the right. Can you see this on the video?
Yeah.
Okay, so now it's up to you guys. I'm just going to keep doing this because I can't write on there. Of ax plus b, right? That's coming in from the right. That's ax plus b. So what's that equal?
2a plus b.
So that's a line or a polynomial. So I can just plug that 2 in for my x, and it's 2a plus b. So what do I have to have? What do we know?
Isn't it -2?
Sorry, thank you. Yeah, it's -2, so it'd be -2a plus b, or b minus 2a. But what do you know about these two values? 4 and -2a plus b. What do you know about the left-hand and right-hand limit at that point?
I do the same.
They have to equal if the limit as x approaches -2 from both sides exists, those have to equal. So I have one equation, which is -2a plus b equals 4. That's one equation, right? Now that's not enough to solve for both, so we need to do it for the other one as well. Okay, so for the limit as x approaches 2 from both sides of f of x to exist, I need to look at that left-handed limit and right-handed limit. Okay, so I'll just use green here. Left-handed limit, so the limit as x approaches 2 from the left of f of x, what graph are we on? Which graph are we on?
The line.
The line, the red one in the middle. There's 2 lines up there, but the red one. So it's ax plus b, right? So now this is what I was trying to do last time. Plug that in for x, and we get 2a plus b, right? And then the right-handed limit is on the other line. So I'll come in with black from the right. So the limit as x approaches 2 from the right of f of x. The f of x I'm at here is 2x minus 6. So I'm on that one. And so I can just plug that in because that's a polynomial, right? And so that's 4 minus 6, which is negative 2. And what do you know about those 2 limits? They have to be equal. And that comes up with our other equation of 2a plus b equals minus 2. So we have 2 equations, 2 unknowns. You have all kinds of different ways you can solve that. We can use matrix theory that I had on the sideboard before. You could graph, guess, and check. You could use substitution. You can always solve for one equation for one of the variables and substitute it into the other one. You can always do that. Or we can use algebra rules. What's an easy algebra rule that we could do here? Elimination by adding these equations together, right? So you can add equations, you can subtract equations, you can multiply through by non-zero constants, or you could also means you can divide through by non-zero constants. But if I add these together, the a's go away, right? And I get 2b equals 2, which says that b equals 1. And then just plug that back into one of them. Doesn't matter which one. I'll plug it into this one, and I get 2a plus 1 equals minus 2, which says that 2a equals minus 3, right? Which says that a equals minus 3 halves. So that's the a and b for the ax plus b. So this equation would be equivalent to minus 3 halves, or equal to minus 3 halves x plus, plus 1, yeah. So these are your answers. Is that what the back of the book had?
Yeah.
Then the back of the book is correct. So you need to do the next problem in a similar fashion, except, I don't know, it might be a little more awkward, might not be quite as easy on 32, but just get all your variables to one side, everything else on the other. So hopefully you can see all that okay. Look pretty good on video?
Yep.
All right, so there you go. And am I recording? It says I'm recording. Okay, perfect. All right, and then there was one, did you want to do number 35 in class? So just look at that one. Instead of me drawing that up, I don't know if I want to draw that up. Let's just look at it. We'll just go around the room here. So basically we've got, maybe I will draw it up. What's it look like? It starts at -1. It goes up to 5. Is that right? Huh? Huh? Well, this one goes to 3, but I meant the graph. Sorry. Or the picture. And then 0.
0 goes to 5.
2 is up at 5, and it goes like this, right? So we have the 0.25 on there. And then we go down at 3 to a height of 2.
And then there's a point at 4.
It's open dot. And then
There's a point
at 3, it's a height of 4.
Yep.
So that's a dot there. And then what's the last thing? It goes at 5, it's a height of 0 again. Is that it?
It's open at the origin.
It's open where?
At the origin.
Thank you. So I didn't, yeah. Because by the way, if it was not open there, since it was closed here, it would not be a function, right? So the origin is open. Otherwise, it wouldn't pass the vertical line test. It wouldn't be a function. So remember, if it's not a function, you can't talk about a limit. So when we talk about limits, we're talking about the limit of a function, which is the height it approaches as x approaches a certain value from both sides, unless we restrict it like we did in section 1.6 to one side. Anyway, so let's go. Number A, the limit as x approaches -1 from the right. What would that be? So this is part A. Who we want to start with? Brett?
0.
Okay, so -1 from the right. Here's -1 as I approach the graph from the right, or at that x value from the right, my graph approaches a height of 0. So part A would be 0, right? Number B, just keep going around, Sammy. Limit as x approaches 0 from the left. As x approaches 0 from the left. Okay, so x is approaching 0 from the left. My graph is approaching this height of 3. Does that make sense? Okay, and then we're going, McKaylee, C, as x approaches 0 from the right. Use different colors. So 0 from the right, my height is approaching that open dot at the origin, right? So that would be 0. Okay. What's the next question? Limit of x approaches 0 from both sides, Drew. Does not exist. So D does not exist. Why? Because the left-handed limit does not equal the right-handed limit. They both exist, but they're not equal. But that's why. Okay. And then E, what's that one? Who's up? Limit as x approaches 2 from the left of f of x. Who wants to go? X approaches 2 from the left. Yeah, it's approaching that height. So once again, if you see the picture, if you see the graph, pretty easy. That's one. Yeah, one young. Hopefully you were staying up late doing legal activities. Won't mention your name, Sammy. All right, 5. So 5. And then what's the next one? The limit as x approaches 2 from the right. No, did I do that one? No. What about from the right? That's also 5, because I'm going up here from the right as I go to the right to 2, my height still goes to 5. So that's F. And then what's G? So G would be limit as x approaches 2 from both sides, which is 5, because the left-handed limit and the right-handed limit both exist and are equal to 5, to a height of 5. You okay with that? You good? All right. Hey, are you related to Al Lowe? Yeah, he's your uncle. Yeah. Don't be going back and telling him, and this is on film, Al Lowe, like, you smile when I come in your room, man. Yeah. He was a little mad. He was mad. He's like, what's this punk in here for? Taking my students. Anyway. Hi, Al. All right. H, E, F, G, H. I don't even know what comes next. You know what I love about Carol? Everybody knows everybody. You know what else I love about it? I'm not related to any of you. I moved in. What's next? You're gonna make me look every time. My eyes are bad. Like, what is H? Who's up?
H. X goes to 3 from the left.
X goes to 3 from the left. What height am I approaching?
3, or not 3, 2.
2. I'm approaching the hole, right? So I'm approaching 2. What's I? Next. You're done. We keep going around. Gracie. I don't know. What's the problem? 3 from the right. I'm going to 3 from the right. It's approaching a height of 2, right? And then what's J? Who's next?
2.
Is that from both sides? Approaching 3 from both sides? Yeah, because these are equal, right? And then K, what's that say? Is there a K?
Approaches 5 from the left.
Huh?
Approaches 5 from the
5. So approaching 5 from the left is what? 0. L, is there an L? There's no L? Well, I got an L. Let's do what the L. Limit is X, what's the L? Limit is X approaches 5 from the right of f of X.
Doesn't exist.
Does not exist because it's not defined, right? So what's the limit as X approaches 5 from both sides?
Doesn't exist.
Does not exist. Okay, I got another L. What comes after L? M. What is f of 3?
4.
She right?
Yeah.
It's 4, right? It's the actual height there, so it's 4, right? What's f of 0? N. F of 0. It's the height at 0. It's 3. Okay, so don't get confused about that. I got one more element, O. What's the limit as x approaches -1 of f of x?
Doesn't exist.
Does not exist because there's no left-handed limit. As you approach -1, there's no graph. Okay? So pretty simple stuff, right? So if you see the picture, this should be an easy gig. Okay, if you don't see the picture, this is why we spend all our time with base graph shifts, etc., that type of stuff. Now we want to get into, 44 was interesting. So somebody asked, I think it was Elijah, do we need to know the definitions? You always need to know definitions in math, right? Because that's kind of the building blocks of the foundations. So that one deals with that. Is there any other questions in 1-6? Those evens are formally due on Monday, yes.
The definition you have to know, do you want us to know like the words or like all the symbols?
Well, I want you to know all the symbols too, but you need to know what the symbols stand for, yeah. Because I'm going to continue anytime I do it again. What's going on? You all right? Like, where did you go? You just left.
I'm listening.
You weren't even looking at me. You were looking out the window.
I can still listen.
Wow. Okay. Apparently females can do things that guys can't. So it's like, what, where'd you guys come from? You been here the whole time? See? Anyway, what was I saying? What was I saying then? You said you were listening.
You were talking about, I asked about the definitions, and you said you want us to know what the symbols mean.
And then every time after we're probably gonna use symbols for stories.
It's those in blocks for now.
Well, I couldn't-
Really? I don't know. I looked away, so I have no idea. All right, thanks. All right. No other questions in 1-6? Now we're going to do a little thing called infinite limits. So I might have said wrong that in section 1, we're going to do continuity, but that's not till 1.8. So anyway, so we have one more section on limits, section 1.7, and it's infinite limits. Section 1.7, infinite limits. Okay, and this, from a concept, this should make sense. What if I have, so let's look at an example. If I have f of x equals 1 over x, what's that graph look like? It's a base graph, right? Arcs and quadrants 1 and 3, right? Well, if I look at the right-handed limit of this, the limit as x approaches 0 from the right of 1 over x, I could put f of x, but I'll just put 1 over x. As I approach 0 from the right on my x-axis, what's my height approach? It blows up. So the closer I get, if I'm at 1/10, I'm at 10. If I'm at 1/100th, I'm up at 100. If I'm at 1/1000th, I'm up at 1,000. And it keeps, as I get closer, it explodes up, right? It explodes up without bound. So we're going to say, so this is, we could say the limit of the quotient is the quotient of the limit. And then, of course, limit of the constant is a constant. And this is the identity. So I can plug in 0. It's 1/0, but what kind of 0 is it? Is it it's not 0 because I can't touch 0, right? I can only get as close as I want. So what I say is it's coming in a positive way to 0, so it's a positive 0. I call that a positive 0, which I know some people's parents would get ticked that I say positive 0 because 0 is what sign? Neither positive nor negative. We all know that, right? But I'm not touching 0. I'm just getting close to it. But I'm getting close to it in a positive way. So if I take a fixed number and divide it by something tiny, what happens to it? It blows up, right? So it blows up, and this is going to blow up to positive infinity, which by the picture of your graph, it explodes up without bound. This is what an infinite limit is. So the right-handed limit at 0 for this function is positive infinity. Does that make sense? Not hard, but we're going to have a formal definition of this with all those funny Greek letters, right? Anyway, and then let's look at it from the left, though. What's the left-handed limit? The limit as x approaches 0 from the left of 1/x. So as I approach 0 from the left, my graph is exploding downward, right? And if I did the same deal, limit of quotient is quotient limit, limit of constant is constant, this would be 1 over what kind of 0? A negative 0, right? Or something approaching 0 in a negative way, which is going to explode this. It's still dividing by a tiny number. It explodes, but it explodes downward because positive divided by negative is negative, right? So that explodes down to negative infinity, which is evident from the graph. If I plug in negative 1/10, you get negative 10, negative 1/100th, you get negative 100, negative 1/1000th, you get negative 1,000, right? And it goes without bound. So, therefore, what is the limit as x approaches 0 from both sides? Of 1/x. Does not exist because the left-handed limit does not equal the right-handed limit. Okay, so we're going to need a little formality with this as well. Okay. So let's see where I'm at. So we're going to need, before we had epsilon delta, but before we do this, let's look at one more. Let's look at x 1/x squared. Okay, so f of x equals 1/x squared. What's that look like? Arcs in quadrant 1 and 2, right? What's the right-handed limit as you approach 0 of 1/x squared? Okay, so it's positive 0 quantity squared is still positive 0, still positive infinity, right? What about from the left? So now I need my other color. Limit as x approaches 0 of 1/x squared. Well, it's 1 over negative 0, but I got to take that quantity squared. So here, this was quantity squared still, which is 1 over a still positive 0, which goes to positive infinity. Well, what about this one? If I square a tiny negative number, what do I get? A tiny positive number. So it becomes 1 over a positive 0, which goes to what? Positive infinity on the left side. So what do you think we're going to say the limit as x approaches 0 from both sides of 1/x squared is? Positive infinity. Now, we never touch positive infinity, so we said the height you approach. It's the height you approach. Infinity is a concept, not a number, right? So Buzz Lightyear to infinity and beyond, that doesn't make any sense. You can't go beyond infinity because you can never get to infinity because it's a concept. Right? Anyway, but we do approach infinity from both sides, so we're going to go ahead and say that the limit from both sides is positive infinity. So hopefully that makes sense. And now let's define this formally then. How do how do we formalize this? Well, here's what we're going to do. We're going to take, by the way, that's like way up there, right? Infinity is way up there. It's not at the top of my board. It's like way up there. Like you can't reach it. It's so high. It's like Jack and the Beanstalk. It would never get to the top, right? Do you know who that is?
Get the top. There's a giant up there.
Whatever, man. Okay.
We're gonna fight the Infinity Giant? Is that what you're saying? That's
You better have me on your team. Figure it out. All right. But anyway, so we're going to take some big ass in. That's what we're going to do. We're going to have some big ass in, and we want to be above that. So I don't care what happens down low where Jack and the Beanstalk live. I want to get past them guys. Toward infinity and beyond, right? So I'm going to have some. You pick some big number. What's a big number? Think of a big number. Huh?
That's pretty big.
25? 45? 45 is big. 89 is big. A Google, it's 1 followed by 100 zeros. Or a Googleplex, 10 to the Google power. It's a 1 followed by a Google zeros. Anyway, those are big numbers. But they're still not big compared to infinity, right? You can still count those, maybe. All right. So anyway, we're going to have some big n. So we need to define what an infinite limit is. So let's do the formal definition for an infinite limit. Formal definition is probably going to mean epsilon delta, right? So first of all, we got to be defined where? Let f be defined on some open interval I, except possibly a itself. So some open interval excluding the set containing a, right? So we got to have that. So I, you just know that's some open interval containing a except possibly a itself. So that's the shorthand way to write that. Then it's basically as x approaches a, f of x increases without bound. As x approaches a, that'd be from both sides, f of x increases without bound is how we say it. Increases without bound. We're not gonna hit the giant. We're gonna keep going without bound. There's no stop to the upside. It's kind of like your potential. Right? There's no limit to your potential. So f of x increases without bound. Written. How do we write that? The limit as x approaches a, in this case from both sides, of f of x is going to equal positive infinity. Equals positive infinity. If and only if. Okay, now what? So instead of what we did before is for all epsilon greater than 0, epsilon was designed to be a tiny number around which axis? On which axis? The y-axis around L, your limit, right? But I don't have a limit that I hit, right? I have infinity that I'm approaching. So what I want to do is I want to take any big ass number for all big ass n's greater than 0. Make sure that's a capital N. Right? And then what? What do I want all my outputs to do? Like when I plug in, what am I going to want?
Bigger number.
Yeah. So if I plug in on the right side, I want it to shoot above that. Okay? So there exists a delta, and then I also want that on the left side. So all these x's that I plug in, I want them to shoot above that n. So for all big ass n's greater than 0, there exists a delta greater than 0, such that what happens? 0 is less than the absolute value of x minus a is less than delta. Is that the same as before?
Yes.
So the only thing that's different in this part of the definition is what?
The n.
The n. So I'll use green for It'd be good to know the differences here. So that one's different. Everything else is the same so far. And then what do I want all these mappings to do? So this will imply what?
Epsilon's bigger than 10.
When I plug in my little x's, my x sub i's, when I plug it in, it's going to have an output bigger than n. So this implies that f of x, any x's in there, is going to be bigger or above that height of n. So if that's guaranteed, if I can find a delta that makes everything shoot above whatever n you want to give me, no matter how big, and if I can do that over and over again, and we do it in general, then that limit is going to be in infinity. It's going to be an infinite limit. By the way, so what else is different in this case? So we still have our delta window around A. In this case, it's around 0, right? So in this case, it's 0 plus delta, 0 minus delta. So I have a minus delta to delta window because it was around 0, right? A was 0 for x squared. Okay, but this could be anywhere. I could have another example. I could have f of x equals 1 over x minus 3 quantity squared. Well, what type of graph is that?
They're both going up, but it's shifted.
Which way? It's a shift. It's a right shift because I would plug in 3 to get 0. So I end up having this, right? And look at that there. There's, by the way, I do have a scale here. So this is 3, but I have a vertical scale also because if I plug in 0, I get 1/9, right? Don't I? Okay. So what's the limit as x approaches 3 from both sides of f of x in this case? Positive infinity. Okay? Because they both explode up. So if they explode in the same direction, then that infinite limit's going to exist. All good with this? Does that definition make sense? So it would be good to actually prove one. And by the way, what would this window be? So let's go to the right. So this is 3 plus delta. So for whatever big ass n that we're going to pick, that's a height. N is a height. It's a big number up. So I'm going to have 3 plus delta to the right, and all these x's are going to map above it. Okay? And then on the left side, 3 minus delta, right? All these x's in here are going to map above that big n. So I just got to make sure I take my delta window small enough to guarantee that. For whatever you give me for n, I got to find that delta small enough. Okay? So I would like to do one of these. By the way, how do you think we're going to do it for a negative infinity?
He's gonna flip this side.
It's a big ass n that's negative, and instead of putting minus n, we'll just say that n is less than 0. And then this would be a minus infinity, and then f of x would do what? It'd map below it, so it'd be less than n. So you could figure that out. That is in your book. So let me just try and do one with the formal definition. Let's prove that for 1 over x squared that we have an infinite limit. So example, you care, and if you got to get going, you can, right? So like I know you got homecoming stuff going on. So Camper kids are grounded, so you can't leave. You don't have crap going on, right? Huh? You gotta get your khakis.
I got class.
Mr. Lowe's class. Then he's really not gonna like you.
Mr. Lowe. Good old Uncle Lowe. Hey, call him Uncle Lowe. Uncle Al. Uncle Al. Call him Uncle Al.
In class, you probably have a commission.
Huh? That's right.
You do something.
Do you call him Uncle Al,
Yeah.
Cindy? No?
I don't call him anything.
Why?
I just walk up to him and talk to him.
You don't. That's not respectful. How do you walk up to me? Hey, dude.
No, I don't.
Like calculus sucks. All right. All right. Limit as x approaches 0 of 1 over x squared equals positive infinity. How are we going to do this? What did we do? So we needed scratch work, right? Didn't we do scratch work? So we had let and then find. Let what? It used to be let epsilon be greater than 0, but now what are we doing? Let n be some big ass number. That's how you say that term in words. So no, Cameron, I don't want you to write that in words. Let n be some big ass number. I don't want you to write that out. I want to see this. Otherwise your parents would be like, what? Seriously, I'm paying for this? Nobody's paying for it. Like, I'm paying for you to be here. I'm a taxpayer. You know that, right? So you owe me, basically. All right. Some people think I want all my students to get A's because that would make me look better. I should say this on film. But if all my students do bad and you fail and you got to come back and take it again, that's job security. So I don't know. So we need to find a delta greater than 0. By the way, most people end up with very good grades in here, just not yet. You're not there yet. Find a delta greater than 0 such that what happens? 0 is less than the absolute value of x minus a. What's a? 0 is less than delta would imply or guarantee that f of x, which is what? 1 over x squared is greater than that big ass n, right? And I don't even need absolute values around f of x. Why? Because it's way positive, right? If I'm going to be bigger than a big positive number, then my f of x would be positive, right? All right, so what do? I work with the finish line to do my scratch work. So what can I do here? Can I get the x squared on the other side?
Yep.
So n times x squared, what happens to my inequality? Stays the same. Why? Because x squared is greater than 0. So since x squared is greater than 0, and then what else can I do? Can I divide both sides by n now? And if I do that, does my inequality change? No. Why? Since n is greater than 0, right? So you have to pay attention to that when we're doing negative proofs for negative infinity, exploding without bound in the negative direction. You may have to be flipping these each time. Depending on what, obviously x squared, you wouldn't flip it. But if we had a negative one, so you might have to flip it. So you do got to pay attention there. So what's this say? So x squared is less than 1 over n. So what can I do to both sides? Let me just rewrite this left to right. So this says x squared is less than 1 over n. But what do I want? I want the absolute value of x is less than delta. So what do I do to both sides here? Take the square root of both sides. And if I take the square root of both sides, what's the square root of x squared? Absolute value of x, technically. So the absolute value of x is less than 1 over n. But they're both positive numbers. So
It's a square root of 1 over n.
Square root of 1 over n, yes. Which is the square root of 1 over the square root of n. So we can say x is less than 1 over the square root of n, right? So guess what I want for my delta?
1 over the square root of n.
So set delta equal to 1 over the square root of n, and then work backwards. So I'll put QED on the board, which means Latin for the rest is finished, but I'll let you finish it in your notes because you got to go. You got big things to do. Good luck. Have fun with homecoming stuff for those of you that have it. And the rest of you, have a great weekend. I'm basically 1.7. You should be able to do those evens as well. So read, work odds, start evens. I'll make that, I suppose, formally due on Wednesday. But we have a major quiz next week. Boom. See ya. The code word is all hail Elijah.
All hail.
All hail Elijah. Ready, break.